The next one. Anybody get the apothem here? 15.28. Fantastic. And that's going to be in inches, right? All right, so again, it's a regular octagon, so area 1/2 AP, right? Is area a variable?
No.
Yes, it is. Okay. And basically, remember, variable just means it's something that changes. Does that area change based on what A and P are? Yes, it does. Okay. So I don't know A, but I know my perimeter. If I look at that number right there, multiply it by 8, that gives me my perimeter to be 100.8, right? Does that give me 770 is equal to 50.4A? And you can solve for A. All right. Now, number 3, in the last class, we looked at this, and we looked at this, and we looked at this, and things weren't kind of panning out the way we thought they should. I don't like this question, because whoever wrote it was a moron, and it wasn't me. This was pulled out of a textbook. That's not 30. Should not be 30. Should be like 27.53. Okay. This is the reason. Let me jump to GeoGebra real quick. So GeoGebra, obviously, you guys understand it does distances and finds areas and all that kind of stuff using the appropriate techniques. And you see it. This is a side length of 4, right? -16 to -12. That's 4. See the area is 27.53. Okay. This here is a side length of 10, and you see it gives me 172.05. In the last class, we went through and we did this. I said, okay, there should be 2 ways of doing this problem. We should be able to take this here and go area is equal to 1/2 AP. Go 1/2. Your apothem here, this becomes 36. This is 5. So your apothem becomes 5 divided by tangent of 36. Okay, all things that we've done in the past. Perimeter is 50. You multiply that stuff out, you get the 172.05. Yeah, you get 172.05. But if I go back and I use what they're trying to get me to use in this problem, where they say that the area of this one is 30, okay, and they want me to use similarity to find the area of this one, okay, I look at that compared to that. What is 4 compared to 10 reduced to? 2/5. And that's your A over B value, right? They want me to use the fact that A squared over B squared should equal what? 425. So that's how the areas of these 2 things should compare. And they do, but when they tell me that this one here is 30, and I need to find this one over here, okay, when I cross multiply 4x equals 25 times 30, you get x to be 187.5. Anybody get 187.5? Okay, so it tells me you did the similarity process correct, but that is absolutely not the right answer for the area of this thing. Because what they do, they rounded things entirely wrong, or very poorly, okay? So my thoughts are that this question, maybe the author wrote this question to a student that doesn't know the 1/2 AP formula, so they can't kind of backtrack a second route or second technique and check it. Does that make sense? But if we do take, let's look at taking the number 27.53, and if I divide that by 172.05, I get 0.1600. Now, there's some rounding there, but if I take 4 divided by 25, you see that those areas then are in the same relationship of 4 to 25, right? So the 30 the 30 compared to the actual 172.05 is a little bit larger than what it should be. Okay, so poorly written question if you're going to use the 1/2 AP technique to check yourself. Okay, so I apologize for that. I should have looked at that prior. Obviously, you can tell I didn't proofread too well when I created this because I do have two of the same questions on here. What about number 4? What'd you guys get there? Say again? I got 3,150. Okay. And whoever copied or whoever let Gage copy off that, they got 31502. Or as well. All right, so we look at these things. The one has an area. This has an area of 80, right? Okay. The other one obviously says when we're looking at these two things, if we were to draw these rectangles, they are similar by a 1:3 ratio. But I don't maybe necessarily need to use that here. This would be the area of this room is 720. Okay. So if it costs me, what they say, $350 to do the small room, can I figure out how much it costs me to do the large room using that kind of setup? Be careful then on it's just your multiplication and then your multiplication or division. You got that right. That's really what I'm concerned about right now. When we use the idea that these two, if we were to draw these, that's 8 by 10. This one here is 24 by 30. 8 to 24 or 10 to 3, those are a scale factor of what? 1 to 3. So then that's A to B. Then A squared to B squared would be 1/9, wouldn't it? Guess what this reduces to? Obviously, you can see it real quick here, right? 0 cancel out with 8 divided by 72. 1/9, right? So you want to use 1/9 equals 350 over x, cross multiply. And reducing to 1/9 maybe allows you to do that multiplication in your head. But that's what we're looking for there, 3150. What about number 5? What do we get there for a ratio of perimeters? 4/3. 4/3. 112 reduces to 4 radical. So 112 over 63. That's an a squared over b squared, right? Okay. So a squared over b squared is 112 over 63. But the perimeters, when we talk about the ratio of perimeters, that's an a over b, isn't it? So I got to square root these things. When I square root the 112 and reduce it, it's 16 times 7. 16 times 7 will give me 112. So square root of 16 is 4. Square root of 7 is just square root of 7. 63 is 9 times 7, so square root of 9 is 3. What happens with those 7s? Cancel out, and now I have 4/3 being my a over b. Okay. How much further does Reggie's sister travel in one revolution than what Reggie does? 6 pi inches. Okay. Now, if you paid attention to nearest inch or something like that, maybe you said 19 inches. If you go to hundredths place, it would be 18.84 inches. Any one of those is fine. Okay. Think about what we mean. And this is going to be useful for 21, and then on the back, when we get to 47 on the back, if we are dealing with circular motion, okay, don't care how big the radius is, okay, but when so let's say this is Reggie's wheel, okay, when he rotates it one time, the distance he traveled after one complete revolution would be that, correct? Okay, the circumference that's laid out on the road in one revolution, that is the linear distance that you travel. And so that's equivalent to circumference, correct? Okay. Now, if his sister's tire was larger, you see that that would be then a much larger distance, correct? Okay. So maybe Reggie's tire is that one, and his sister's one is that one. Okay. Obviously, she traveled a further linear distance. So how do we find those two things? All we got to do is take the circumference of Reggie's sister and minus the circumference of Reggie. So, circumference, maybe in this case, pi d is an easier formula. Circumference for Reggie's sister would be 26 pi. Circumference for Reggie would be 20 pi. The difference in those then is 6 pi, right? Okay. I think that helps us here when we get to this last question on 21. It says a Ferris wheel has a 50-meter radius. All right, and wants to know how far a person travels if this thing goes around 10 times. So you're sitting in a Ferris wheel seat right here, and you're going to go around it, right? And if you go around it one time, what would you be traveling around for that circle? Circumference. So circumference is 2 pi r, right? 2 pi times 50, so I have 100 pi. Now my units would be meters, correct? Because that's what my radius was in. Okay? That's one revolution. How many revolutions are you going to make? 10. So I multiply that by 10, and I get now the total distance to be 1,000 pi meters, correct? Okay. What's the question ask you, though? Kilometers, right? You guys know from science maybe that King Henry died by drinking chocolate milk. Okay, now that's deca, that's deci. These are your bases of meters, grams, and liters, right? Okay. But what's nice about this, guys, is that this is simply telling us that this is basically our units. Okay, and units are 1, right? Or referring to 1. So this is actually a power of 10 raised to the 0. This is 10 raised to the negative 1. That's what deci is. That gives me like 0.1. This would give me 0.01, so that's negative 2. So that's hundredths. This would be 10 to the negative 3. This is 10 to the first. This is 10 squared, and this is 10 cubed. Okay, and that's how that SI system is built, off of a base of 10. And then the powers of 10 are those components, deci, centi, milli, and that actually keeps going on. There's a lot of units beyond that, okay? You've heard of micro and nano and things like that, right? Well, those are further to the right in that slide, okay? There are things that are further to the left than kilo, okay? You guys have heard of, think about just computers, okay? We have kilobytes, we have megabytes, we have terabytes, don't we? We have gigabytes, okay? So tera, giga, mega, those are higher powers of 10, okay? But that's the one that you probably use the most in science, correct? Okay, those 6 units. And using a slider here is 100% perfectly fine. But I want to make sure that we understand how to use this thing appropriately and when we can use it. This is a slider for units. Don't get crossed up with these powers of 10. This is only for units that are to the first power. So like meters to the first power, grams to the first power, liters to the first power. Okay? So these are only for kind of linear ideas. Does that make sense? So if I ask you to convert meters squared at some point to kilometers squared, you don't use that slider directly. Does that make sense? You can't use it, but you've got to add something to it, or add a concept to it. This is only for things to the first power. So you guys know that if I'm in meters, I'm at that base right there, and I want to get to kilometers. I just count over 1, 2, 3, and I move my decimal place 3 spots, right? Now my decimal place here is actually right there. It's not behind the pi. Does that make sense? Okay. Move that 3 spots to the left, you get 1.0 times pi, which is just what? Pi. So pi kilometers. It says obviously around the nearest tenth, but if we leave it as pi, it'd probably be better. If you wrote 3.14 kilometers or 3.1 kilometers, you spent every time looking at that set of directions in the question, that's obviously fine as well. Is it okay? Now, I'm a person that I like that slider, but if I'm in the English system, if I'm in feet, inches, miles, maybe we're talking about masses or pounds, ounces, that type of stuff, there is no slider because it's not a consistent base, right? Okay. Hopefully, obviously, if I look at distance, inches to feet is a base of 12, right? Feet to miles is 5280. Okay, it's not consistent. Okay, 5280 is not a power of 12. And then if we go over to masses and volumes, they change as well. They're not a consistent base, and that's why there's only 3 countries in the world that really use the English system. Okay, everybody else uses the metric system. So I want you guys to learn the process for converting because it is important. Because if I dealt with feet or something like that, how I'd go about doing that. So if I started with 1,000 pi meters, and I want to get that to kilometers, okay? And there's a lot of different ways of doing this, okay? But, or at least a lot of different ways of multiplying here. My overall goal is to start with this solution in meters, and I want that meter to disappear and generate kilometers. So what you end up doing is you say, okay, if meters is here, I want it to cancel out. So meters have got to go there. Does that kind of make sense? Okay, because that will give me meters over meters when I do the multiplication, and they will provide me a multiple of 1. They cancel each other out. So now the question is, do I know a direct path from meters to kilometers? Does anybody know how many meters there are in a kilometer? Yeah, there should be 1,000. Oh, put in the wrong spot. There should be 1,000 meters for every 1 kilometer. Okay, kilo means 1,000. Does that make sense? It's 10 to the third. 10 to the third is 10 times 10 times 10, which is 1,000. Okay, so that's the kind of the math behind the slider that works every time. Does that make sense? Okay. What's going to happen with my 1,000s here? Yeah, one's on top, one's on the bottom. They cancel out. And what's the only thing you're left with? A pi. And what's the only units you're left with? Kilometers. So you got pi kilometers that way. Okay. I prefer that, and you're going to see why I prefer that when we get to the last question on the other side of the page. Okay. Those of you that have dealt with chemistry and molar masses and Avogadro's number and all that kind of stuff, heard me say it before in here, you probably understand how to use those conversions, okay? Because that's what we got to do in those situations. What'd you guys get for 35 here? Six pi minus 9 radical 3. Okay? Pretty easy to find the fact that that sector is 6 pi, right? We do 60 degrees over 360 times pi r squared. Multiply 1/6 times 36 gives you 6 pi. Okay, so there's your sector. What's a quick way for finding the area of that thing right there? Yes, s squared radical 3 over 4. Because that's an equilateral triangle, right? And that's the formula to find the area of an equilateral triangle, where s is your side length. So we get 36 over 4 times radical 3. Or what's 36 over 4? It's that 9. Okay? So 9 times bracket 3 then. If you found the area of that 1/2 BH, that's fine. Absolutely, it works. It's just more time consuming. Okay? That's always the thing you want to think about when you're doing math problems in general. Look at the components that provide you with. Do they open the door to an easier process than just brute force doing the same exact way that will always work, but might be time consuming when it does always work. Does that make sense? Okay. What did we come up with for the area of this window? 1.5 pi? No, that's absolutely right. 3 pi over 2. Some people have been saying 1.5 pi or 1.5 pi. You're going to find out that this is the preferred way of using or writing an answer. Okay, it's kind of what I hate about early on mathematics is that they tell you that mixed numbers are what we want to use. We want to go 1.5 pi, right? The only reason you learn those mixed numbers in middle school is because you're starting to try to develop an understanding for fractions and what they mean to you, and that means you have 1 whole pi and 1/2 a pi, right? Okay, but that thing stands 1.5 pi as a mixed number. That thing stinks for later calculations. Okay, where 3 pi over 2, if I want to square that, I square the 3, I square the 2, I square the pi, right? Where in 1.5 pi, and I want to square that thing gets kind of messy squaring. Okay, so for improper fractions, even though they've got the word improper attached to them, okay, they are the best ones to kind of lead your answer to. Okay, for the rest of high school. How do we find that? If I take everything that I just shaded in, can you find that area? Yeah. Because this arc out here is 45 degrees, right? Okay. So what is the radius of that circle? Careful. What's A to P's length? 4. It's the same as P to R, right? Okay. So when we look at the semicircle, we're going to find sectors of semicircle. You want to draw this whole circle, you could. But that is 4. So can I say 45 over 360 times pi r squared? 45 over 360 is 1/8 times 16 pi. Does that give you 2 pi? Okay. So everything that's blue right there would be 2 pi. Do you have the ability of finding the area of that green region? How big would this arc D to C be? 45. Anybody know why? If I look, so I'm hearing, I think, the correct arguments here. If I look at that central angle, isn't a central angle equivalent to the arc that it intercepts? So that'd be 45, right? And now use the converse of that. The arc that is intercepted by a central angle has to have the same measurement. Would you guys agree that that arc is intercepted by a central angle of 45? So now work my way back out and say that has to be 45. So now finding that green area, it's still 45 over 360, which is still going to reduce to 1/8, right? Now what would be the pi r squared for this green circle? 4 pi. So 1/8 of 4 is 1/2. So pi over 2. So 2 pi and pi over 2 are those two areas individually. What do I need to do with them to find the area that we're really interested in? Okay. Yeah, but the algebra says subtract them first, right? Okay. Now, using what you said, combine like terms, but maybe I can recognize that they both have pi in them. When I factor that pi out, it gives me 2 minus a half, right? Is that 3 halves? And 3 halves times my pi, 3 halves pi. Doable? I said it yesterday, and Jenna shook her head. This one's nice. Anybody get 36 root 3 minus 18 pi? Good. What kind of triangle is this? Equilateral. That's 6, 6, 6, 6, 6, 6, right? So 12 total. Do you have the ability finding that area? That's squared radical 3 over 4, right? 144 radical 3 over 4. Turns into 36 root 3. Okay? That's the area of that. What is the area, or what shape is that red stuff? It's a, what do you call it? It's a sector of a circle, right? In that sector, that angle right there is going to be 60 degrees, right? Nowhere in the problem does it tell you that. You have to know that if it's equilateral, it implies that's equiangular, right? So I get 60 degrees over 360 times pi r squared. Well, pi r squared, this is going to be 36 pi, right? 1/6 of 36 is 6 pi. So that red is 6 pi. Well, how many of those red regions would you have here? 3. So timesing that by 3, I get 18 pi, correct? So what do I do with the 18 pi and the 36 radical 3 to find that blue region? Subtract them. Okay? Later on, this is what's going to happen, guys. I'm going to give you a question. I'm going to say, in chapter 12, we'll start talking about volume. Okay? Does that kind of look like maybe like taking some pop cans and stacking them together, putting them together, and looking down on top of it, right? Okay? And if I say I want to put those pop cans in a box, okay, I want to know how much wasted volume I have in that box. Does that make sense? Okay. So you kind of project that into a three-dimensional image, and you've got a lot of those little blue regions that are three-dimensional columns that are taking up wasted space, right? There's nothing in there. Okay. So I'm shipping air as a maybe Pepsi distributor or something like that. And I want to think, okay, let's put my math people to work and say, okay, how can I save money on shipping? Okay, because I don't like shipping things that are putting boxes out there that are empty. Does that make sense? Or have wasted space. So those are things that we'll be looking at in the next chapter. But this question is going to help us get there. The next one, hopefully the next one wasn't too bad. Did you guys get 35.68 for the diameter? Okay, 35.68 for the diameter. 166.66 square feet for the second part. Think about that second part. Now you could run through formulas and all that kind of stuff. But it says we're going to rotate it 60 degrees and only rotate 60 degrees. So how much is 60 degrees of a circle? 1/6. What is the area of the circle that this sprinkler will cover? 1,000 square feet, right? So 1/6 of 1,000 is 166.666666666666 square. So 166 and 2/3, right? Okay. Now this next one. These are, I think, good questions in the event that you are going to, I know some of you have maybe aspirations of taking higher level math classes, aspirations of taking physics, higher level science classes. You do this on the regular in those courses, okay? So let me get this in a better window so we can do a little bit of work. I've already shown you today the idea of a tire traveling on a road, right? Okay. So this tire It's 70 centimeters in diameter, and that's pretty accurate for like your average racing bike. Okay, probably not. I don't know about like mountain bikes or anything like that, but this is pretty average. Okay, so if that's my diameter, how far would I be traveling if this thing just rotated one time? If my diameter is 70 centimeters, this thing rotates one time, what would that relate to in regards to a linear distance? 70 pi, right? Centimeters? Okay, because it's the circumference that you're laying out on the road, right? Circumference is equal to 2 pi r, or in this case, maybe pi d. Does make sense to be used here. You got 70 pi. That is one revolution, right? How many revolutions are you taking every second? 3. So if I multiply that by 3, do I get 210 pi centimeters in 1 second? Does that make sense? How many seconds are you doing that for? 60 times 5, right? You're doing that for 300 seconds. Okay? What's 21 times 3? 63. What's basically 10 times 100 is 1,000, right? 3 zeros. And then I still got my pi, correct? So that's centimeters, okay? Now, make sure that we're paying attention to this because I want to get this into, this is the answer that I asked for when I had the A and S right here. You're putting 63,000 pi centimeters. I want to now know what's the average speed, okay? And this is where I want you guys to pay attention and make sure we understand how to do this because it's going to be a component to a lot of questions later on. What is speed? How do I find rate? That's what I mean when I say speed. Okay, you know distance is equal to rate times time, right? So then distance divided by time is equal to rate, correct? Okay. What distance did he travel? He's traveling that, right? And what time did he do that? 5 minutes, okay? If I divide those, I have an answer. I have a rate in centimeters per minute. But do you ever travel in a car that says centimeters per minute? No, so you probably don't have a very good experience with that kind of rate and wouldn't know how fast that is, okay? So I want to convert this. Why I asked you to do it in miles per hour. Let's convert this to miles per hour. So in my end result, guys, I want MI over HR. That's miles per hour, correct? So I'm going to choose, and it doesn't matter which one. I'm going to start choosing one of my units and see if I can get it to disappear. So let's just start with centimeters. If I started with centimeters, it's in the numerator. Somewhere it's got to show up in the denominator, right? So I'm going to put it right there. They would cancel, correct? Do you know how to go from centimeters straight to miles? I don't, okay? But hopefully we know, we've seen this before once in this class, or maybe we can use Google, that for every 1 inch, there's 2.54 centimeters. Okay? Now centimeters cancel out, and now I would have units in inches per minute. But do you ever travel in a car that says inches per minute as their speed? Nope, so still don't have any familiarity with that. I want inches to go away, so I'm going to put inches right here. Do you know how many inches there are in a mile? I don't. But I do know how many inches there are in a feet, right? Or in a foot. Okay? So 1 foot, 12 inches, correct? Now I would have feet per minute. Maybe you're starting to get closer to an understanding of how fast feet per minute is, but your car wouldn't tell you that. So let's get rid of feet. So feet's got to go there. Do you know a relationship between feet and miles? Yes. Yes. 5,280 feet for every 1 mile. Okay? Now, earlier I said, do you know how many centimeters go to miles? If you were to multiply this stuff out right here, that would get you the centimeters to miles number. And you can remember that if you wanted to. I don't think that's a good idea. If I multiplied everything out, I would have miles per minute. Getting closer, right? Okay? I need minutes to drop out. And minutes need to turn into what? Hours. So minutes are down here. So in my next thing, they need to be up there, right? That's the only way I can get them to cancel out. Do you have a minute to hour ratio?
Yes.
How many minutes? 64. 1 hour. So I would take on my calculator, I would take the 63,000 pi times 1 inch times 1 foot times 1 mile times then 60 minutes. It gives me that number. Okay. I would then divide that by my denominator, which was 5 minutes, times 2.54 centimeters, times 12 inches, times 5,280 feet, and you are traveling at 14.75 miles per hour. Is that something that you can kind of envision? Get my car, go 15 miles per hour, how fast is the first on the bike? Okay. We're going to do more of that, okay? But hopefully you guys have some, those of you that are in chemistry at least, have some background in doing it, okay? If you're not in chemistry this year, but you're going to be next year, by the time you get there, then you're going to be ace. All right? No new homework tonight.